Okay, the next problem is problem 6. Here's the function. It's a little hard to see, but it asks where it's decreasing. Decreasing from -3 to -1. So let's say -3 to -1. But it's also decreasing from 2 to 3. 2 to 3 right here is going down. So I have to give both those intervals. And I think it wanted a U right here. Let me double check that real quick. Yeah, it wanted a U. So sometimes Webwork is picky. You know, a comma won't work in this case. You need that U. All right, the next problem is problem 7. We have this function right here, and it wants to know where it's increasing. Definitely graph this and find out from the graph where it's increasing. So go to Desmos and you should see this. This one actually has an end behavior asymptote, which we'll talk about later in this class. But it's increasing from -infinity all the way up to 1.41. And this is also 1.41. So we'd say from -infinity all the way up to -1.41. And then as well as from positive 1.41 all the way up to positive infinity, it's increasing if you look at this graph from this point on forward as well. Okay, next we need to figure out where it's decreasing. So it's decreasing then, if you look at this, from this -1.41 all the way to 0, and from 0 to positive 1.41. So we'd say that -1.41 to 0, as well as 0 to positive 1.41. All right, the next question asks the x value of the local maximums and x value of the local minimums. So once again, the x value of the local minimum here is 1.41, and maximum is -1.41. So local maximum -1.41 and minimum 1.41. Now, Webwork might want more than rounded to the 100th. So if that's the case, if it's not accepting these answers, you might have to scroll in and get another decimal place like 1.414. Sometimes Webwork's really picky about the numbers that we use, so keep that in mind. Okay, here's the next problem, problem 8. It gives us this graph right here, which I've made a little bigger for us. And it first asks, does this graph represent y as a function of x? So we need to answer that question. Let's just check the vertical line test for that. It does pass the vertical line test. You know, even this point right here, if you draw a vertical line through, it actually only intersects the graph one time right there. So it does pass the vertical line test, therefore it is a function. And then the domain they want, the domain is all the numbers from -2, 3, 4, 5, from -5 all the way up to +8. So we'd say from -5 to 8, and we can include those points. And then the range is just the point 4 right here. And then obviously all the values from -2 to 3 as well. So 4 and -2 to 3 would be B right there. All right, the next problem gives us a piecewise function. It gives us a line for whenever the x values are less than -3 and a parabola for whenever the x values are greater than or equal to -3. So I think it's important to graph this just so you can see what this thing looks like. So here's the graph. The line is x plus 3. It's got a slope of 1 and it goes through 3 for the y-intercept. So a slope of 1 is up 1 over 1, or back 1, down 1. And so it's an open circle there, and it goes back like this. Okay, so I'll do that in a thicker color now that I've got it. That's the line. They only want to graph for the x values that are less than -3, so I put an open circle here and back to the left. Now the parabola I'll do in red. That one's a parabola that's been shifted up 7 units. So 1, 2, 3, 4, 5, 6, 7 is here. And I need just a regular x squared parabola. Now, I don't know what exact point this goes through. I can find it by plugging in -3. If you plug in -3 here, you get 9 plus 7, which is 16. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's up here somewhere, 16. So I didn't draw it very well, but you get the idea. So it's defined, let's pretend at this point 16. It's defined there on this parabola, but not anywhere to the left of that, right? Because it only wants the x values that are greater than or equal to -3. I know it should be up here, but that's good enough. So the domain then is going to be all real numbers. This is a function. It does pass the vertical line test. The domain is all these values to the left, this point, and then all the values to the right. So the domain is all real numbers, which is -infinity to infinity. And then the range is a couple of different intervals. It's this interval down here, which is going to be all the y values that are less than 0. as well as, so I should say or, all the y values that are greater than 7, greater than or equal to 7. So in interval notation, that would be negative infinity all the way up to 0, not including 0, as well as 7 all the way up to positive infinity, and I can include 7. So that would be my answer in interval notation for this. And I'm not sure if they want interval notation or if they want inequality, so you might have to try both of those, but one of those should work. Yeah, they wanted me to enter it in interval notation, so that worked fine. All right, next problem 10 wants us to find the domain of this function. I know we could graph it, but let's do it algebraically. And I might check your work if I were to ask you a question like this on the test. I know we've already done this, but let's do it again. We know that 25 minus x squared has to be greater than 0. It can't be equal to 0 because it's in the bottom. And that would give us 0, which is undefined. So this thing has to be positive, strictly positive, because we can't have negatives underneath square roots. So that's what we're solving, that inequality. Different ways to do this. Probably the easiest way to do this one is without the sign chart, because you can actually get x by itself. Normally we'd make a sign chart for this, but we don't need to in this case. I can divide by -1, which changes the sense of the inequality. And then I can square root both sides, which gives me x is less than 5, or x is greater than -5. And I need to actually use the word and there, because if you go to make a sign chart or a graph, a line graph of what this solution looks like, it's all the values that are bigger than -5 but less than 5. And I can't use those endpoints. So it's all those values that are okay for the domain. Anything else is not okay for the domain. So I'd say -5 to 5, and it wants interval notation, so -5 to 5 like this would be the domain. Then next it wants us to find the vertical asymptotes. There are more than one. Vertical asymptotes occur at zeros at the bottom, and that's in your formula sheet. The zeros at the bottom occur at 5 and -5. So we'd have x equals 5 and -5 for our vertical asymptotes. If you plug in 5, you get a 0 on the bottom, which obviously is undefined, and that's our asymptote. So 5 and -5 for that. All right, the next one wants us to find the x and y intercepts of this. X and y intercepts are easy to find because an x-intercept is wherever y is 0. So plug in 0 for y, you get x squared equals 49. Square root, that's plus or minus 7. So the x-intercepts are plus or minus 7. And the y-intercepts are easy to find as well. It's where x is 0. Plug in 0 for x, and you get y squared equals 49. So once again, that'd be plus or minus 7. And they want them separated by a comma. They do want them entered in like this, so this isn't going to work. I'm going to have to enter them in as ordered pair. As ordered pair, they would be 7, 0 for the x-intercepts and -7, 0. And the y-intercepts would be 0, 7, and 0, -7, separated by a comma. Okay, the next problem wants the average rate of change. So this is in this homework assignment. We haven't talked about average rate of change yet, but it's just slope. What it wants is the slope. Whenever you see average rate of change between these 2 points. So this is actually a line. This g of x line has a y-intercept of 6, and it's got a slope of -7, so it goes down like that. And they want the average rate of change between these 2 points. Well, you can go ahead and do it. You're going to get 7 if you do y2 minus y1 over x2 minus x1. -42 over 6 gives you -7, but we already knew the slope's -7, so average rate of change for between any 2 points from this line is -7. And then it wants to know if the function's increasing or decreasing on the interval from -3 to 3. Well, this function's always decreasing, so you can go ahead and say that function's decreasing. All right, the next problem then is another average rate of change problem. It says for each interval given below, decide whether the average rate of change is greater over a particular interval between these 2 functions. The dotted line is g, and this growing sine or periodic function is f. So the average rate of change from 5.2 to 8. 5.2 to 8 would be from here to here for the f, so that's a negative average rate of change. And then for g, it'd be here to here, which is positive. So obviously the average rate of change is greater for g. than it is for F. So for the next one, G is greater here. For the next one, 5.2 to 6.1, so I'll do G in red. 5.2 to 6.1, that's always the same, by the way. 5.2 to 6.1, you're always going to have the same average rate of change for G because it's a line. So it's always going to be that slope. And then for the function F, 5.2 to 6.1, it's this purple line, which has a much greater slope. So we would say F is greater in that situation. Next one, 2.2 to 4. 2.2 to 4, I'll just draw a purple line in again for the slope for F, and obviously G is greater because it's a red slope. So G would be greater there. And then 2.2 to 6.1, 2.2 to 6.1 is here. That's actually the same slope as the red one, so they're the same in that situation. And then 2.2 to 6.9, 6.9 is right here. That's got a lesser slope than G, so G would be greater in the last one as well. Okay, I hope this helps.